All right. Hi, everybody. My name is David Holtzman. I am a Al Gore trained climate reality leader from the Climate Reality Project. Going to give you some short hits on climate change. And here we go with part number one, the first part of part number one. Like I said, I'm here with the Climate Reality Project. And I have a quick question for you. Now, your professor didn't want me to go all into election reform today. He said, talk about climate change, not election reform. Election reform, instant runoff voting, a big interest of mine. But I'm going to do something election related right now, democracy. Since I don't have you all on camera, I need you to speak up loud and clear. Taking a quick poll here. All right? Um, Yell if how you have reacted to climate change so far, global warming, is that you have been dismissive. Nobody has been dismissive. Okay. How about have you been doubtful? Yell if you've been doubtful.
Yeah.
Okay. Okay. Here's some doubtfuls. Yell if you've been disengaged.
Yep.
Oh, disengagement. That's a hallmark of your generation. Sorry, kids. Cautious. As people have been cautious. I have a hand, but you got to yell for your vote to be recorded.
I'm cautious.
Cautious. Okay, we got a cautious. And how about a concerned?
I'm
Yeah.
concerned.
Okay, we got a concerned contingent. How about alarmed?
I am an
All right, well, I see like two or three alarmed. Okay, that's the freak out contingent. Very good. This is the results of a poll taken of Americans and their attitude towards climate change. As you can see, you could come up, if you look at these circles and add up the numbers, you could come up with a majority of the population who are cautious, disengaged, doubtful, or dismissive. That would be a pretty big majority. So, you could also come up with a mainstream, or excuse me, a middle of the road majority, 29% plus 25%, that's going to be 54%, that is concerned and cautious. Alarmed is sort of on the edge, dismissive is sort of on the edge. So the battle these days politically is between the concerned, cautious, and the, there we go, laser pointer, cautious, disengaged, doubtful coalitions. So you might take some action here. You certainly would take some action if this was the majority, but 16 plus 29% is not a majority yet of voters or people in America. These are the thought steps that the Climate Reality Project hopes people will follow. First, it's real. Second, it's happening now. Third, it's caused by us, that's humans. Fourth, science and industry agree. And fifth, we can make a better future. I think I'm here, the better future part, I'm still a little worried. But let's see why. One, all right. Picture a bright blue ball just spinning, spinning free, dizzy with eternity. Paint in the skin, the sky, brush in some clouds and seas. Call it home to you and me. A peaceful place, or so it looks from space. A closer look reveals the human race. Full of hope, full of grace is the human race, but afraid we may lay our own to waste. That's the beginning of a song called Throwing Stones by the Grateful Dead. Happen to be a deadhead myself, so I throw in that as a personal touch here. Whenever I see a slide like that, I think of picturing that bright blue ball just spinning, spinning free. This part is about understanding the atmosphere and how the atmosphere works and how that relates to the warming of the planet. This slide shows you just how thin a layer the atmosphere really is. When you back up in space and put a telephoto lens on an edge of the Earth and the sun's just coming up, you can see the atmosphere, there's the laser, is just this thick, but the surface of the Earth goes way out both ways. All right, so this is obviously not to scale, the sun and the Earth. The sun emits light, and the solar radiation from a light wave hits the Earth, warms up the Earth. But the Earth, when it emits its warmth, the warmth comes out as a different type of energy, infrared waves. Some of the infrared waves bounce back and are held in by the atmosphere, by the gases in the atmosphere. It's called the greenhouse effect. The greenhouse effect works in a greenhouse, but not everybody knows what a greenhouse is. That's where you grow plants indoors and keeps it warm. But everybody here, this is the greater LA area, probably knows what happens on a summer day when you leave your windows closed in your car and you get in. The energy has come in as light. It's warmed up your car. The warmth from within your car makes infrared waves which don't get through your glass as well, so your car just keeps getting hotter and hotter. And that's what's happening on a smaller scale to the Earth. Fortunately, the creator of the Earth left the window cranked down a little bit, but we're kind of plugging up the holes with our climate warming gases, and that's no good for us. All right, so you would think that the distance from the sun is going to be what determines how warm a planet is. But that's not the only thing. Another thing is how thick, how big the blanket of carbon dioxide and other climate warming gases, the gases that reflect back that infrared radiation is. So Venus is a lot hotter than Earth, but it is closer to the sun. So you're going to say, oh, okay, but how about Mercury? Do you think Mercury is hotter than Venus? The answer is no. Mercury is not hotter than Venus. It's a lot cooler than Venus, and that's largely because it has this thinner layer. If we get more carbon dioxide, methane, other climate warming gases in our atmosphere, we're going to warm up. Even though we're further away than these other planets, we're going to get closer in temperature to Venus. Not like hugely close, like 457 degrees C, which the Climate Reality Project likes to point out is hotter than the melting point of lead. I don't think we're going to be walking on molten lead, but we'll be getting hotter without moving closer to the sun. That's the key point there. All right, a little movie showing you about a 4-degree swing from the early 1900s, or 1884 actually, to 2011. The blue is -2 Celsius, like white is average, and then when you get towards yellow and red, as the years go by, 83, 84, 85, 88, 90, 95, 96, 2000, whatever, you get towards the red, which is 2 degrees higher across the surface of the Earth, except, as I like to point out, over here in California, right around here, the whole west coast of the United States, we don't see the effect. So just because we don't see the effect, remember, it's a global average, and climate change is really getting more and more significant away from where we live. Although, keeping your real estate along the coast here is probably going to be pretty valuable because it's just going to stay nicer here. We're just so fortunate in California. All right, that's the end of part 2. Here we go. All right, so just in case that last movie didn't work, here's just 2 slides that show you a swing not in the surface temperature, but in the amount of ice that's covering the North Pole. And you can see that between 1980 and 2012, same time of year, the Arctic has lost more than a third of summer sea ice volume since a decade ago, and even more, it's only a fifth now of what it was since 1980. Things are happening, and of course when ice melts, if it's floating on top of water, that's fun. You're not going to change the level of the water. Like if your ice melts in a glass, that's fine. You don't change the level of the water in the glass. But if ice melts from on land and flows into the ocean, you're going to have a rise in sea level, which is one of the major concerns about climate change. Anyway, but this part is more graphs. There's more graphs and a little bit of visual understanding of the issue. What we have here is a record since 800,000 years before the present, BP, of carbon dioxide concentrations. And you can see they go up and down, up and down, up and down. And if you add in the historical record of temperature, you can see that the up and down, up and down, up and down temperature has followed the up and down of carbon dioxide concentration. You can see that the temperature rise comes up a little, maybe just slightly after the carbon dioxide concentration. That's what it looks like to me. But anyway, if you were to tack the present on here, it would barely move the x-axis here because it's 100,000 years. And if I was to put the most few recent years on here, like I'm doing now, look at what the carbon dioxide concentration just zooms up to. In the historical record, I mean, it's never been above like 300 or so. And now it's already 400. There is still a public interest organization called 350.org. 350.org I thought was one of the dumbest names for an organization because nobody knew what it meant. Who knows what it meant? Okay, well now you can tell what it meant. It meant we have to keep the concentration of carbon dioxide below 50 parts per million in the atmosphere or there's going to be a crisis. Well, tell you what, we've already got a crisis. It's past that, according to 350.org. And I think they have good reason to say that a lot of things are going to change even if we stop emissions of global warming gases. So that's 2013. Let's tack on a few more years. Oh, yes. All right. The current rate of increase after 40 more years will be way up to 600, and that's just off the charts of the historical record. It's dangerous. It can and would be bad. We need to try and stop that. In the movie, An Inconvenient Truth that Al Gore did, Al Gore has to come over and get on like a crane-like thing to go up with his, physical, not laser pointer to follow that. It's a very dramatic part of the movie. Anyway, so that's just carbon dioxide, and one way of looking at it visually, that things are really different than they ever have been before. Another thing is watch the distribution of temperature events change throughout time. All right, so this is what the average has been in 19 to 1980, this whole time. You have an average temperature, on the weather forecast, the average temperature for today is, and then the difference between the average temperature and the actual recorded high temperature is, if it's a lower temperature that you experience than average, you put a blue dot here in the graph, and you put it according to how far below the average today's temperature was. If it's a higher temperature today or than the average, we color it red, and we fill in this area under here a little bit with the red. So this is the average for, what is that, 50s, 60s, 70s, 3 decades. The decade of 1981, after it, to 1991, you can see already the temperature bands are shifting so that they're a little more, about, I don't know, quarter degree higher on average than it used to be. And then here, the mean of the curve is about 1 for 1991 to 2001. That's 2 decades ago or so. The last decade, 2001, 2000, it's just creeping up. And a lot of people say that 2 degrees Celsius is a threshold at which we're going to start seeing serious melting of glaciers if that's the change in the overall average from 1951 maybe mean to now. Once we get to 2 degrees Celsius, which is 3.6 degrees Fahrenheit, it's something to worry about. That's what they say. But of course, that number's got to have a lot of wiggle room. So whenever you see a news report that says, we have to keep it under exactly 3.6 degrees Fahrenheit, know that they only chose that because 2 degrees Celsius is what most of the world was thinking of, and 2, 2.5, 1.5, it's all fits in that range. All right. So, interesting fact that the extreme temperature events used to cover 1/10 of 1% of the Earth. Now they cover 10% of the Earth that has extreme temperature events, more than 3 degrees different from average for a summer. All right, so one more thing to know in this part, where the warmth is going. Water absorbs and keeps heat better than land, and well, ice reflects it because it's reflective, and continents, and 93.4% of the warming is going in the ocean, which is really causing problems for marine ecosystems. A longer talk I'm not going to give here. But it also suggests that once water starts melting on glaciers, it's going to stay melted and then start melting away, and perhaps causing more calving of glaciers and rise of sea levels. All right. Another just way of looking at the heat content of oceans. The long line here is the, I guess, 5-year moving average, and pentadal average, that's 5 years, right? And then there's the yearly average, which is sort of taking in mid-2000s, as well as a 3-month average. And all these numbers are showing that there's just a steady monotonic, which means ever increasing increase in the amount of heat in the oceans. And this slide just compares it to the heating of the land, etc. The oceans, beginning of the food chain for a lot of species and ourselves, it's taking a big hit, changing the pH, changing what can grow in the oceans in different places, messing up fishing, etc. And that's the end of part 3. All right, here's a graph showing just weather catastrophes. Storms, meteorological events, green bars, hydrological events, flood and mass movement, I guess, as mudslides are these middle sort of grayish, bluish bars. And then just extreme temperatures and drought and forest fire, climatological events are the tops of the bars. What's key to note here is that it's these middle bars, floods, like I mentioned, water was key, that are really getting fatter relative to the others. And that's of major concern. Floods can be deadly, as we know. And here we get into, why is this happening? Is it just natural, or do humans play a role? Well, Ray, I'm not even sure how I said it. It's Munich Re. I think it's Re for reinsurance. Re's are the companies that back up other insurance companies. These are the ones that are really doing the insurance for the world. And they agree that the only plausible explanation for the rise in weather-related catastrophes is climate change. So they know that the risks are higher. Of course, they're charging higher premiums. And they won't lose any money in the long run because they never do. Another reinsurance company, the other largest reinsurance company in the world, says that keeps them up at night. The CEO, what keeps us up at night is climate change. We see the long-term effect of climate change in society, and it really frightens us. All right, so here comes the linkage between the climate crisis and extreme weather events, the things that keep those insurers up all night. Again, a similar chart to the end of the movie I showed you, the temperature anomalies. You see that there's quite a lot of red. There's some blues where some parts of the world are getting cooler, but usually it's out here over the ocean, what have you. But right along California, it's actually getting slightly warmer, but not much warmer. And again, I don't know. We're blessed here. We may not notice, but the rest of the world, East Coast having some problems, the whole Mediterranean up here, Scandinavia, down here, South America, around the deserts of Africa, places to worry about, because these sorts of changes can cause mass migrations of people and political instability. Which is why the Defense Department, I might mention, is very interested in climate change and how to mitigate it, and which is why there is a climate change awareness group that's called the Truman National Security Project. And they're all about how we need to fight climate change to protect our national security. So remember that name, the Truman National Security Project. They're a good resource if you want more information on the national security implications of climate change. All right. Of course, we're nationalistic, so we'll zoom in on our nation. And now let's go back out to a worldwide view, and you can see the jet stream, which if you ever fly cross country, you know can affect how fast your plane moves cross country. It also brings weather events across the country. It used to follow the dotted line, and now partly because these areas of the world are warming, this represents glaciers or sea ice. The purple is areas that has disappeared. The jet stream can come a little further north and it swings a little further south, but mainly just swings a little north and brings down cooler weather sometimes in the East Coast. And I think you might have heard of Polar Express or something like that, weather phenomena, Arctic Express. That's been caused by this change of the jet stream. If you move this line, take this line and shove it over here, because the jet stream moves west and east, you can see that the jet stream is bringing air from further north, where it's colder, down to the same latitudes that it used to. And sometimes it does it here, say over New York and that area. This is just a sort of time-lapse image of a serious storm, a band of storms called a derecho that happened in June 2012. You can see this really strong band of storms just really didn't lose intensity as it marched across much of the eastern part of the country. And that's the sort of thing we didn't see before. National Center for Atmospheric Research, Kevin Trenberth, points out that global warming is contributing to an increased incidence of extreme weather because the environment in which all storms form has changed from human activities. And storms really are influenced by the ocean. Again, water and warming of water is very important. And main thing that happens from climate change and the warming of the average surface temperature of the Earth. Okay, another linkage between extreme weather events and adverse system impacts in general, impacts on our systems. Couple of slides here, a couple of pretty pictures. One, when glaciers melt, they uncover stuff. And one of the things they'll be uncovering in Alaska are reservoirs of methane, which is natural gas, which is like what we use when we're cooking on gas stoves. A lot of houses are heated by natural gas, what have you. But methane itself is a really potent climate warming gas. It's 20, 30, I forget the exact number, times per molecule effective at causing global warming. And it's thought that if all these seeps of methane start because the glaciers and the permafrost in Alaska melt back, uncover them, and let this methane get into the atmosphere, it would counteract the beneficial effect of half the trees essentially in the world. Half are what are called carbon sinks in the world. Trees are called carbon sinks because they take in carbon dioxide, clean the air of carbon dioxide, and as you probably learned in some biology class somewhere, in the process of photosynthesis, help turn that into sugars and what have you. And they're structural elements. So this is something to look out for. If you can't control methane, you let methane get into the atmosphere, you're going to have quicker global warming than you otherwise would have had. Although methane doesn't last quite as long as carbon dioxide does, but still, it'll cause problems worse and faster than an equivalent amount of carbon dioxide. And you may have heard the controversy over fracking, where you push under pressure liquids underground to break up the ground to get oil and gas from underground. One of the problems with this is sometimes it's resulted in leakage of methane. Now, methane is actually a cleaner burning fuel than the products of oil in terms of how much carbon dioxide is emitted from the burning. So Al Gore and others like to call methane a possible bridge fuel. It's good to use natural gas, have a natural gas car, what have you, while we're working on developing more renewable sources of energy. But here's the break-even point, if 3% of the methane that you're recovering from a fracking well escapes, it totally undoes the benefit of using methane instead of oil-based fuels as a bridge fuel. All right, one more pretty picture, but bad fact. Every day during the growing season, the temperatures go above this 84-degree Fahrenheit level. Corn yields go down by a small fraction, but cumulatively, it's estimated that by the end of the century, U.S. corn yields could fall by 1/3 just from heat stress alone, just from more of these days that are harming corn yields. So again, at the bottom of our food chain is where we're going to start seeing the initial and eventually cumulatively damaging effects of climate change. All right. And a graph. Corn yields, crop yields, fish yields affect food prices. And for some reason this is over since 1990 to 2013, for some reason recently we've had a couple of spikes in food prices, probably resulting from some sorts of crop disruptions and extreme weather events. I'm not sure the details, something you could look into further. One more thing climate change is doing is making it better for infectious diseases to proliferate. Um, Another thing you could look into, I'm not going to go into the details, but the hosts are moving into areas where they can thrive a little more for infectious diseases. Um, Air pollution is affected by climate change, so particulate matter and pollen. Uh, when it gets hotter, you get more pollen going through the air. Uh, um, Specific to North America, on average, there's this grains of pollen about 8,500 in 2000, but by 2040, it's going to be a lot bigger, about 22,000. So that's the thing. Grab a tissue, something to start crying about, but I don't know, allergies aren't as serious really as the other stuff I was talking about, in particular the disruption of the food chain and the resultant human migration that we're going to have, and pressure on borders and national security. So that's the end of part 4. Move on. I'll try and welcome to part 5. This is the part where we nail down the fact that humans are affecting our climate in ways that are causing climate change, that is causing adverse effects on our environment. It's consensus. The word consensus comes from the word root con, which means together, like a conference, is people coming together, and sense what we're thinking. So generally people all together who've looked at the issue think this. In fact, watch this scroll. Every National Academy of Science of every major country in the world confirms anthropogenic global warming. Anthropogenic. Anthro has to do with humans, people, anthropology. And genic has to do with Genesis, creation. So all these academies of science agree that humans are creating climate change. The American Meteorological Society is one of many scientific groups that agrees. I put this up there because you may notice when you watch the weather report on the news, your weathercaster sometimes puts up certification from the AMS from this particular group. And well, I don't know, I think it's great. Weather people these days, you may have noticed, are hot, but not in a climate sense. I don't know why, but the weather people on the air have gotten more and more attractive. It's another qualification for being a scientist these days, apparently. Anyway, so watch the hot news, and you'll see it gets hotter. The society has really laid it out nicely. They say human activities have become a major source of environmental change of great urgency are the climate consequences of the increasing atmospheric abundance of greenhouse gases. That's from your Hot Weather People Society. I like Kai Goldberg, by the way. If anybody watches him, I like partly his name. Anyway, good guy on Channel 2. Not an endorsement. But guess what? It's not just scientists. It's even companies that think this sort of thing. ExxonMobil says rising greenhouse gas emissions pose significant risks to society and to ecosystems. Strategies should promote fundamental shifts towards energy efficient technologies and practices across the economy, and the more prominent use of fuels with lower carbon intensity, such as natural gas, nuclear energy, and renewable fuels within the overall energy mix. Well, two things there. One, they don't want to get rid of their primary products, but two, this tells me that they're going to be investing in these renewable sources, or at least the sources with a lower carbon intensity, because this is business, and they're going to want to sell you what they think people are going to want to have. And I think people are going to want to have these other fuels to protect the planet. That's not just ExxonMobil. How about Dow Chemical, one of our most favored companies for the environment, right? Look at that. They say the climate threat warrants bold action, and the world must respond with comprehensive, far-reaching solutions. And there's a URL you can go to read more about what they think. One more thing they think is that a global climate change strategy is necessary to outline clear steps towards slowing, stopping, and reversing the growth of greenhouse gas levels in the atmosphere. In other words, it's already too high, that line we saw. We've got to actually bring it down at some point in the future, or I don't even want to go there right now. It could be bad. I look at this slide and I say, pick your company and make a joke about it. I mean, these are some of those companies everybody in the world knows, and they all agree that climate change is something humans are causing and something needs to be done about it. So I'm going to bring the mood up a little bit now, if I can. We can make a better future. We have the technology. We can rebuild him. This is a really lousy reference to the $6 Million Man, the TV show that was on when I was younger. We have the technology. We can rebuild him. We have the technology. We can rebuild the earth or remake our activities to protect the earth. So if we act now and decisively, we can make a better future. So here's some of the basics. What's causing the problem? Carbon dioxide from fossil fuels and unburned gases like methane, which is a fossil fuel. Reduced carbon sinks, trees going away, deforestation. The trees take their sinks because it's stuff that takes the carbon dioxide away out of the environment. Less of them around. That's the problem. So what are the solutions? Well, one is obvious. Reduce and stop using fossil fuels. I'll probably end up driving my gas-burning car until it dies, but after that, I'm going to try and get a car that runs on something better. To increase carbon sinks, reforestation, plant a tree, do things like that. People are talking about just putting big vats of algae out there, just that might absorb carbon. Then you could use the algae perhaps as some sort of fuel in a particularly environmentally beneficial way. There we go. Top scientists in the journal Science said humanity already possesses the fundamental scientific, technical, and industrial know-how to solve the carbon and climate problems. We have the technology. We can rebuild him. All right. We have the solutions at hand. It's a pretty picture of one of the types of solutions. What the hell? In the middle of the water, build huge wind farms. All right. This is not an oil drilling rig. It's a windmill construction rig, putting up a windmill. Look at all the other ones here in this area. This particular one can power 470,000 homes, and it's just off London in England. How about a solar farm? Well, this is one of Britain's 2 largest solar farms. It's built on the site of a reclaimed tin mine. What the heck? You got some area? Let's do it. There are companies around here that will look at your house and tell you if your house is suitable for getting enough solar panels on top of it that you can save money on your electric bill and pretty much generate most of your daytime electricity, or all of your daytime electricity by doing that. So that's the end of part 5. We have the back to the bright blue ball just spinning dizzy now with eternity. See what we can do to make it better. But let me ask you again. Global warming or climate change, whatever you want to call it, how are you reacting to the subject now? Verbalize your answers, please, because I don't have you on camera. Are you now dismissive of the subject? Well, I don't think anybody was before. Nobody is now. How about doubtful? Is anybody now doubtful of the subject? I got a hand, but I didn't hear a verbalization.
Still doubtful.
Still doubtful. 2 still doubtfuls. 3 still doubtfuls. Okay. And I need some more work on you guys, I guess. How about disengaged? I guess anybody disengaged now? At least people have been engaged with my presentation. If I haven't convinced them that it's something to worry about. How about cautious? Who would say that now I'm cautious about climate change? I'm just going to make sure I don't do anything to mess up the planet. See some nodding, but you got to verbalize it or else it's not going to be on the table. Okay. A little bit cautious. How about concerned? People who are concerned? Yell it out. Okay. And how about alarmed? We got an alarm this time. Okay. Anybody else? All right. Well, usually presentations like this will nudge people a little bit down this list. Or to the left again on this slide, which will expand these circles eventually. And again, politics, I think eventually the political consensus will develop around here that will lead to better action nationally and even internationally to protect the planet from the adverse effects of what's going on here, which could be severe. So here are some things you can do. 1, speak up. Don't let the denial of climate change go unchallenged. Use social media and traditional media to get the word out. There's a hashtag you can use, or a reality. If you want to get sort of like written sound bites, but word bites that you can drop in to the comments fields on websites to counteract wrong statements that you see on the web. Go to realitydrop.org. The whole point is why they call it reality drop is you're dropping the reality onto the websites. You can write letters to the editor. You can call radio and TV stations, or you can go and get trained by Al Gore. I got trained in Chicago. Last time he did it, I think it was in Australia. But I think he does one in the U.S. and one internationally every year now. All right, personal choices. You can make a difference. Every little bit makes a difference. It's like voting. Every little vote can make a difference. The professor told me not to get political, like I said, but I did hear from him that he did poll the class on who had voted, and the number he gave me about the number of people who had voted in this class was rather disappointing to someone 15%. Like me. 15%. Lovely. All right. Anyway, how about boosting that number for helping protect the climate, helping protect the world? Make consumer choices that reduce your energy use. Consider the environmental impacts of the items you buy. Improve the energy efficiency where you live, in your workplace or school. Think about the new LED light bulbs, light emitting diode light bulbs. They may cost a little more, but in the long run you'll save money, and I think they last a lot longer than regular light bulbs. Just one thing you can do. And you can dim the LEDs since you couldn't dim the compact fluorescents. And the last thing you can do is change laws. It's even more important than change light bulbs. Change the systems. Support putting a price on carbon. There's two ways to do that. There's two political ways to do that. One is just to tax carbon. Tax the carbon content, the greenhouse gas potential of the fuels that are used, the energy that is used to power our world. Empowering our world, empowering what we do, we are putting out a pollutant that's filling up that little space between the ground and the top of the atmosphere, and it's something that needs to be regulated. One way to do it is to disincentivize the worst types of energy and incentivize the good types of energy, like solar and wind power, by putting a price on carbon, a tax. Another way to do that is to set up a trading system where people have credits based on the amount of greenhouse gases they've been historically emitting. You say that's the number of credits they're going to get, and if they figure out a way that they can cheaply reduce their emissions of greenhouse gases, they can sell those credits to somebody else and reduce their own emissions. And then you make the price of the credits get higher, you remove some of the credits from the economy, from the trading system, and that's another way of bringing down the amount of greenhouse gases that are emitted. A carbon tax can easily be repealed, so a cap and trade system is more likely to be permanent. So, getting back to politics again, tell your leaders this matters to you. Let them know you will support or strongly oppose them based on what they say and do about solving the climate crisis. So, that's the end. Fin in the cinematic term.